anybody that didn't come tonight because of the weather or any other reason, you can tell them that if they go to the OCI website, and I went to resources events and I got to here, I'm going to be basically repeating the talk I'm giving tonight as an online webinar that is free. You scroll to the bottom of the page, there's a place to sign up to attend that.
We can put a link in the meetup group.
Yeah, that's why I was starting.
Okay.
You can do that.
You're gonna do this again tonight, later on?
In 2 weeks,
Oh, in 2
around
weeks.
2 weeks, yeah, not tonight.
They say you do.
So all the slides that I'm going through tonight are at this URL. It's my GitHub, mvolkman/talks, and there's a bunch of sets of slides there. This is just one of them, and all my contact information is there. So my plan is to go over all of these tools, and we'll see, can I really do this in an hour or so? I don't know if I can. But if I can, you've got the slides, and these numbers here are the slide numbers, so you can jump to a particular thing that you're interested in. So these, to me, are some really nice tools to use with JavaScript development. And my plan is for each one of them to tell you what the tool does, what are some alternatives you might consider if you don't want to use that one, and how do you configure and use these tools. And so the way I'm going to do this is I'm going to walk through this demo app. It's as simple as I could possibly make it. As an input, you type something in and you press greet and it will say hello to you. I wanted to keep this simple so that we could focus on the tools. It does not use a particular web framework. It's just raw JavaScript and DOM so that I don't bias this toward any particular framework. You can find all of this code also in GitHub. And then these are the files that make this up. It seems like an awful lot of files for something so simple. But the reason I broke it up this way is that I want to show using ES6 imports and exports. And so I had to have more than one JavaScript file so I could demonstrate that. Okay. And so to get this running, I said npm run build and then npm run sync. And so one part of this is watching my files and reproducing a bundle every time something changes. And then this part is refreshing the browser anytime something changes. And we're going to get into the details of those coming up in just a bit. So let's start with npm. And so the purpose of npm is to install node packages and to manage all the dependencies in your project. And then the part I really want to focus on is for scripting common tasks. And there are other things you could use for scripting things in JavaScript. You can use grunt or gulp, but an awful lot of people have left those behind and tried to do a lot of their scripting with npm scripts, and we'll see what that looks like in just a bit. And of course, npm is also used for installing things and managing dependencies, and you could use yarn for that instead. And at one point, it was a really good idea to use yarn instead of just raw npm. But now a lot of enhancements have been made to npm, and there's not as much of a reason to use yarn these days. So to get npm, well, if you install node, you get it along with the ride. You could install it separately, but I don't think there's really much of a reason to do that. npm, what does that stand for? Well, once upon a time they said it was Node Package Manager, and now for some reason they're just adamant that it does not stand for that. To which I say, yes it does. So I don't understand why they don't want you to think that. There's a lot of npm commands you could run, but this is a pretty good set of common things you'll want to do. So when you're starting a project, you run npm init, and it asks you a bunch of questions about your project, and it creates for you a package.json file where all your configuration is going to be. Then if you want to install some packages, you do an npm install. Maybe you'll add a -d in there to say that this is a development dependency instead of something you actually need at runtime in your application. Then once you have this package JSON and another developer is going to work with you, they get a copy of that. They just say npm install. It looks at the package JSON, sees all the dependencies, and installs everything for them. So that's a beautiful part of this. If you do add some scripts to your package JSON, the way you run them is to say npm run and the name of the script. But there are some special script names where you don't have to say run, so sometimes you can omit that. So the npm scripts are defined in a package JSON, and a lot of things you don't have to worry about what platform you're on. It won't matter if you're on Windows or a Mac, it'll just work. But there are some things you might want to do where you have to think about this. So there are many libraries to help with this to make your NPM scripts more popular, more portable. One of the popular ones is SHX, for portable shell commands for Node. And then another thing you can do for working with environment variables in a portable way is to use cross-env. And so here's an example of some scripts that might go in a package JSON. And so I have a name for each of these, and then what is the script command I want to run. So if I say npm run clean, then it's going to run that command. Now I have some notes up here. A couple of these use npm run all, and that's so that I can have a script that runs many other scripts in sequence. And that's what I'm doing here. And of course, if you want to use that, you've got to install npm run all. And you'd want to do that as a development dependency, because it's not part of your application. It's just for running these scripts. And then the two that have the pink highlighting, these are the only two on this slide where it wouldn't work in Windows. And so for this one, you could use SHX, and it has its own command for deleting things. Here I'm just trying to delete my build directory and my coverage directory. And then for this one, I'm using the open command, which on a Mac, it determines based on the file you're opening what would be the default application that just does it. But that doesn't exist on Windows. But there are many packages in NPM that do a similar thing, and one of them is called Opener. And so you could use that in place of this if you want to make this portable. Now all of these scripts I'm going to be going over as we get to each of the tools that utilize it. The only one that we won't see again is the verify. And I like having something like that where in one command I could say, could you please check my code and tell me if there's any problems? And there are many pieces to this. I want to run a linter on my code. I want to do some type checking. And then I'd like to do test coverage and see if I have enough tests written. And so just by saying npm run verify, it'll check all of those things for me. So now we're ready to jump into specific tools. And the first one I want to hit is ESLint. And so this is a linting utility for JavaScript. It's finding not only style kind of issues in your code, but also things that really could be a problem at runtime. So there are some alternatives to this. JSLint from Doug Crockford. That's a much older tool. And I don't know, getting a little opinionated here, I think that Doug got a little crazy at some point. And a lot of people have stopped using this tool because it's just so incredibly opinionated. You can barely configure anything about it. JSLint got popular because it was more configurable than JSLint. But then ESLint came along and had so many more options, and people were writing plugins for ESLint. And so at this point, it is so much more powerful than any of the other options. If you happen to be working in TypeScript, then you could use TSLint instead. So some details about ESLint. When it outputs an error message of something you violated, it not only gives you the message, but it tells you the name of the rule. And that way, you can say, oh, I don't agree with that rule. I'm going to configure that one differently, and you know exactly which one to change. It has a -- fix mode that can fix a lot of violations. So rather than it just saying, hey, you forgot a semicolon, it can put the semicolon in for you. So a lot of rules have a fix mode like that. So if you want to use this, you install it by running that command. And I'm installing two things here, ESLint and then also Babel ESLint. That last one is optional, but you want to do that if you're using features in your code that require the use of Babel. Like new features coming to JavaScript that aren't in all the browsers yet. You'd want to use Babel ESLint so that ESLint will be able to parse that code. And then you'll add a script in your package JSON that looks like this. So I'm telling it, look in my source directory and find all the .js files and check all of those. The -- quiet says, don't tell me that you ran successfully, just tell me if you have any errors. There are IDE and editor integrations for this, for pretty much anything you'd want to use. If you're not using one of these, you should talk to me later and tell me, why are you not using one of these? These are definitely the most popular.
Yeah.
Oh, did I? Yeah, okay.
So I really like ESLint, and I'm trying to move some things to TypeScript. Does ESLint have a plugin for TypeScript, or do I need to move to TSLint for that?
I'm not aware of it having that. As
Okay.
far as I know, you have to go to TSLint.
Well, that's a bummer.
Yeah. Okay. And there are other plugins you might want to use depending on your environment. Like there's one up there for React, but try to not make this specific to a certain framework. So then you get into the rules that you want to check in your ESLint. And out of the box, it doesn't enforce anything. You have to have a set of rules. Now, you can use someone else's set of rules, and a lot of people do that. Or you can look through the list of hundreds of rules and decide for each one what your preference is and build your own configuration file. I actually was bored a few years ago and did that exact thing and decided what I wanted for each one. And then there's another thing you can do that I don't have listed up here, a thing you run that tells you whether your ESLint configuration file is missing configuration for any of the current rules, so you can find out if there are new ones that you haven't set yet. There are many ways you can code up the configuration. I think the most popular is to do it in a JSON file, but there are other formats you can choose if you want. And then when you run ESLint, no matter what directory you're in, it's going to look to see, is there a .ESLint file in that directory, one of these configuration files. And then it'll keep looking up until it gets to the top of your project. And if it finds more than one, it just combines them all. And the closest one to the directory you're in is the one that wins if there's a conflict. So I want to try to demo this for you. So I'm going to jump over to my terminal window here. And let's see if you can remember what I had planned to change. Okay, so I'm going to go into one of the source files of this simple application. And I guess I should show you down here that if I say npm run lint right now, I don't currently have any errors. And now I want to introduce some errors. And so I'm going to come up to this function, and I'm going to get rid of a semicolon, and then change a letter there, and then run that again. Okay, and now I've got two problems. If I scroll back to that, it's telling me I'm missing a semicolon, and then the function handle greet is not defined anywhere because I just changed the name of it. Of course, if I undo those changes and save my file, run that again, everything's written down. I cannot imagine working in JavaScript without using a linter like this.
Right.
Okay, next thing I want to hit is Prettier. So this is an opinionated JavaScript formatter. So I just kind of railed against other linters for being opinionated, and now I'm going to praise this tool for being opinionated. And that's because people can waste a lot of time trying to argue over coding conventions. And I'm definitely guilty of that myself. I've had very strong opinions about the way I wanted my code to be formatted. But when this tool came along, I noticed that it did almost everything the way I would like. And so I tried it for a while, and I decided, you know, it really is kind of freeing to just let this tool do it and stop worrying about it. It's also nice that if you're on a team and people are wanting to write code in different styles, if everybody has to run Prettier on their code, it's amazing that when you're doing a code review, you're no longer distracted by the way they wrote their code, because now it looks just like yours. So I really love this tool. It can deal with more than just JavaScript, many other kind of syntaxes it knows how to handle. Initially, this was the way it was described, that it parses your code into an abstract syntax tree, and then from that, writes it out however it wants. That's not exactly true anymore, and that's why the word any is kind of highlighted there. Now they say, well, actually, some original styling is preserved, like where you might add some blank lines and how you might format a multi-line object. But for the most part, you shouldn't assume it's going to maintain anything that you did. So it can format a lot of kinds of things. There are alternatives. There's a thing called standard that is kind of popular. But for me, that's a no-go for two reasons. One, earlier we were talking about semicolons. With standard, no semicolons. But the other thing that I think is really weird is that in standard, when you want to call a function, like if you have a function called foo, it puts a space there. It's just so odd. I don't know anybody who writes their code like that. And it'll reformat all your code to have that space if you use standard. So I like Prettier. So very easy to install. You want to install it as a development dependency, and then you can set up an NPM script like this. Might name it format. You want to run Prettier. You can give it some options to override some things, and I'll show you a list of those, I think, on the next slide. And then this --write says I want to overwrite the existing files. I don't want to just see what it would look like if it was formatted. Go ahead and actually do it. And then you tell it what files to format. And the tricky thing here is that if you don't put these quotes around this glob pattern, what that means is that your shell will interpret it instead of Prettier interpreting it, and you won't be processing files that are directly in the source directory. But if you add the quotes, then the glob pattern works like you probably expected. So you don't have to put the configuration here. You can create a .prettier.rc file and do that as JSON. It doesn't try to prettify JavaScript files in the node modules directory, which is good. You want to touch those files. And there's lots of editor and IDE integrations available for this. A lot of people love it because they set it up in their IDE, and every time they save, it just automatically reformats the code. So there's not a lot of options. As I said, it's an opinionated formatter, but these are some of the things you can override. The ones with stars are the ones that I choose to do some overriding on. And so I don't want to spend a lot of time looking at this. You can check out the slides later and see which of these you might want to override. Another related tool is Prettier ESLint CLI. Earlier I told you how ESLint has this fix mode. But you might want to run Prettier on your code and then run ESLint with the fix mode so that you could override some of the things that Prettier is doing. So that's an interesting option. And if you want to do that, you just install that, and then in your NPM script where you were saying Prettier, just change it to prettier-eslint and you'll have it. Whatever fixes are available in the way you have ESLint configured, those will be applied after Prettier runs. There is one caveat to this, and that is that Prettier knows how to format CSS, but Prettier ESLint does not. And so if you wanted to do both things, you need to have a separate NPM script, one that's for your JavaScript that uses Prettier ESLint, and one for your CSS that just uses Prettier. And of course, if you're using some CSS preprocessor, maybe Sass, well then you don't care about that. There's no point in formatting the generated CSS. Okay, so I want to demo some things in Prettier. I'm going to go back to my code, and again, I'm going to remove a semicolon. And then I'm going to really mess with my indentation here. Okay, that's pretty ugly. And then I'm going to come over here and npm run format. And it tells me that it formatted a file. And so I'm going to come back to my editor and reload it and see if it fixed that. And sure enough, I got my semicolon back and it fixed all my indentation. Okay, next thing I want to talk about is Babel. Some of these tools you won't have to worry about if you are using some framework that has some starter thing for you that sets it all up. And in my case, I'm specifically referring to working with React and using Create React App. I highly recommend that if you're working with React. And then you don't have to set up things like Babel and Webpack. But I'm not going to assume that, so I'm going to show you how to set them up anyway. And you might want to do this if you're working on a server-side piece, maybe a node.js server, then you'll want to set this up anyway. So Babel transpiles JavaScript code into different JavaScript code. And it lets you do several different things. It lets you use features in an environment where it's not supported yet. So it could be an official thing in JavaScript, but this one environment, maybe this browser doesn't support it. And so you can transpile to code that will work in that browser. It will let you use features that aren't finalized yet in JavaScript because you want to use them anyway. Like you want to use object spread. Yes, you do want to use that. And so you can with Babel. Or you could use features that may never be a part of ECMAScript. Like you want to use types, maybe using flow. Then Babel will let you do that. There are alternatives. Really the only serious alternative is TypeScript. TypeScript is doing two things for you. It is a transpiler, and it also gives you some extra language features. And I'll talk more about TypeScript later. So installing it is really easy. You install the Babel CLI. You almost certainly also want this, Babel preset env, and I'll talk about what that does on the next slide. And then to set it up, you just need an npm script that runs Babel on everything in your source directory. The -d says, I want to put the transpiled code into a directory called build. Okay? So you don't need this if you are using Webpack to bundle up all your code, and Webpack is configured to use the Babel loader. So in my sample application, because I am using that, I don't need this too. I put it in anyway just to show that you could use that just by itself. Okay, so we'll talk about bundling later, but the question there is, do you want to take all your JavaScript files and combine them into one so that it will load faster in the browser? Or if you don't care about that, you're okay with having separate files, you could just use Babel and it will write the separate files into that build directory. So there are a lot of plugins for Babel, but I want to highlight 3 of them. And the most important is Babel preset env. So in the configuration file for Babel that we're going to see on the next slide, you can tell it what you're targeting, like what browsers do you care about, or what version of Node do you care about. And Babel will look at that and say, oh, well, based on what you're targeting, you don't need certain things done for you because I know that environment already supports it, and so I won't transpile certain things. Or you want to target IE8. I got to do a lot of transpiling for you. So that's a really good plugin. If you are using Flow to add types to your JavaScript, then you're going to want this one, Flow strip types, because code that has flow types in it isn't going to run anywhere. Something has to pull it out after you've done the type checking. And then the last one I mentioned, the object spread operator and the rest operator. That's a feature that's coming to JavaScript soon, and I'm not waiting for it. I use that constantly now as a quick way of saying, I want to create a new object that's like some other one. I'd like to take its properties and spread them out inside this new object in my literal object syntax. So that's one I highly recommend. So if you want to use any plugin, you just need to install it as a dev dependency and configure it in the .babel RC, which looks like this. So it is just a JSON file, and so presets is one of the things you can specify, and then you tell it about the environments you want to support. So I want to support the last 2 versions of every browser, and I'm also targeting Node version 8. So Babel will look at that and decide what kind of transpiling it needs to do. And then I'm using these 2 plugins, my flow strip types and object spread. Some of these plugins have some configuration options. So this one, use built-ins, is telling it how it's going to transpile the code to support the object spread. Is it going to use its own polyfill, or will it use object assign? So depending on the plugin, you might have some configuration options. So this is a really quick demo. I'm going to notice here that I do have a directory called build. And I'm going to delete that. Now I don't have a directory called build. And then I'll do npm run Babel. And now I do have a directory called build. And I'll look at what is inside that directory. And come up a little higher. I've got a demo.js file, I've got my test file, my index.js. I had those same files in my source directory. Those are just transpiled versions of those 3 files. Okay. Then I want to talk about using types in your JavaScript code. So why would you even want to do this? Well, it lets you find errors before you try to run your code rather than discovering them when you're testing the code. It lets you document your expectations, like what do you think is going to be passed to this function? What are you planning to return from this function? It definitely helps with refactoring. I was not always a fan of putting types in my JavaScript code, but I've been on enough semi-large JavaScript projects that it's really great that if I decide this object that I'm using all over my code, I no longer want it to have this one property, or I'd like to change the name of that property. Or it used to be a string and now it's going to be a number. What would happen if I make that change? I don't even spend any time thinking about it. I just make the change and I run Flow, and Flow says, you just broke these 4 files on these lines, and then I go fix it. That is such a great thing for increasing your confidence in doing the refactoring. And then, of course, you no longer need to write tests that are doing type kind of checking, and you don't need to check for it at runtime in your code. You can be sure that it's going to have the types that you specify. There's a lot of editor and IDE plugins to support this so that it can show you the type errors right in your editor. With all that said, there are reasons that you should not use types. It's going to take a while to master the syntax of putting these in and master being able to apply them. It also makes your code look more verbose with all that type information in there. And if you're trying to prototype something or develop something rapidly, it's going to slow you down. So the only reason you're doing this is for the future benefit of all the errors it's going to catch for you and how it's going to make refactoring better. But initially, it's slowing you down because of the learning curve to go through and just having to type all that extra stuff. So with that in mind, when should you use it? Well, if your application is large or it's complicated or it's a really important app, when you expect this code to live for a long time, so it's probably going to have to be refactored. And when you're working with a team of developers, I think it's a really good idea. But if those things aren't the case, you're working on a simple app, you're the only one working on it, it's not going to live a long time, maybe you shouldn't bother with the types. But suppose you decide to go ahead with this. Well, you really have just two options. There's Flow and there's TypeScript. So first I'll talk about Flow. So that's a static type checker that finds errors in your JavaScript code. And the important thing is that it does this through type inference and flow analysis. So you'll specify some types, but other things it will figure out for you. It will watch, what did you ever put in that variable? Okay, I see that you only ever set it to a string. What happened to that variable? Well, it got passed to this function, and that concatenated something, and it passed it down to this other function, and what did that do with it? And so it's following the flow through your code, trying to figure out if there might be a problem somewhere. So it's precisely tracking the types of all your variables. And another great thing is that you can step into this gradually. If you've got an existing application, you can configure Flow the way I'll show in just a bit. And then you can take a single source file in your app and say, I want to use Flow in this one file, none of the rest, and get some benefit out of that, and gradually add it to more of your files. So it's not an all or nothing sort of thing. So the alternative is TypeScript. And TypeScript, as I said earlier, is doing two things for you. It's adding types, and in fact, it looks almost identical to Flow types. I would say the syntax is at least 95% the same. But there are some differences, and TypeScript is also being the transpiler for you. And so I'll say a little bit more about that in one more slide. But just some details about using Flow. So it supports all the ES6 and most of the ES6 Plus features. It has a lot of support for React and JSX, but it's not specific to that. And so to install it, you need a bunch of things installed. So npm install -gd, all of these things. Okay? So it's unfortunate that it takes a bit of setup, but all the information is right there. Another really important thing is that you've got to have a file that is .flowconfig. And to get that file, you just say flow init, and it will create it for you. In most cases, you don't even have to edit that file. But one reason that this is important is that if you're in any directory and you run flow, it will search for that file. And if it doesn't find it, it looks in the parent directory. And if it doesn't find it, it looks in its parent. And it keeps going up and up and up. And finally, it will hit your home directory, and it won't find it. And then what will it do? You might guess it would say, I can't do anything for you because I didn't find the file. That's not what it does. What it does is it says, I bet you wanted me to check the type of every JavaScript file on your hard drive. And you will know this has happened because the fan on your machine will spin up and your CPU usage will spike, and you'll be racing to kill all the flow processes. Not just one process. It starts a bunch so that it can check the files in parallel. And so on my machine, it starts 10 flow processes. So do not forget to create that file. Lots of editor integration so that you can see the flow errors right in your tool. There's so much I could say about this. I have a set of slides that are there, and I also gave a talk on this at a conference, an hour-long talk. And so if you go there, you can just watch that whole talk. So back to TypeScript. Why am I seemingly promoting Flow over TypeScript? Well, here are some reasons why I like Flow better. One is that Flow does a better job of catching errors without you adding any types, because it's doing the type inference and the flow analysis. And TypeScript does a little bit of that, but not nearly as much. And so I can show you a simple example where there's clearly a type error and Flow catches it and TypeScript does not. TypeScript basically says, I'll do this work for you if you tell me the type of everything. But if you don't, I'm not guaranteeing anything. The other thing is that in Flow, strict null checking is the default. If I say a thing is a number, it has to be a number. It can't be null or undefined. But in TypeScript, the default, at least used to be, that anything could be null or undefined. It wouldn't check for that and complain that you didn't set a thing. Now in TypeScript, if you set it up using this -- init, it will give you a configuration that does the same thing as Flow, but that wasn't always the case. Another one that seems a little more abstract to talk about is that Flow uses nominal typing and TypeScript uses structural type checking. So why is it bad to use structural type checking? Basically what that means is that objects are compatible in TypeScript if they have the same properties, and that's it. In Flow, if you create objects from classes, they are compatible if they were created from the same class. And so an example of this is that I could have a cat class with a name property and a person class with a name property, and then I declare this variable to be of type cat, and then I create a person object and I assign it to the cat. And TypeScript says it's all good because they both have a name property. TypeScript says, our Flow says, you told me classes of these things, they're not the same class, so I'm going to complain if you do that. Another thing is that Flow just does type checking, whereas TypeScript is doing the transpiling too. On the surface, that seems like it's a good thing. Two benefits for one out of the same tool. But I think it's kind of bad because Babel is such a popular tool in the JavaScript space, and people are creating plugins for Babel all the time. I want to use Babel. So if I use TypeScript, I still can use Babel, but then I have to tell TypeScript, would you transpile my code to ES6, and then as a separate step, take that and run it through Babel. And I don't really want to do that two-step process. And then the last point here, I like that Flow only adds types. TypeScript is adding some features to the language which may or may not ever become part of JavaScript itself. And I don't really want to work in this separate dialect of JavaScript. I want to work in the JavaScript language. So a quick demo of Flow. I'm going to change the type of a parameter in one of my functions, and let's just do that one for now. So my get greeting function. So back to the code here, and first I'll say npm run flow and show that right now I don't have any errors. And then I'll jump over to the code, and my get greeting function name is a string, and I'm going to change that to be a number. Over here already in my editor, it's complaining. I've got all those thumbs down icons because I just broke it. Yeah, I've got 5 errors now just because I changed that type from a string to a number. Do that. Run it again. Okay, and back to good. So, really like Flow. Next tool I want to talk about is Jest. This is a tool for writing tests for your JavaScript code. It's very popular in the React community, but it's not specific to React. And so it's built on top of the Jasmine framework. It uses a thing called JS DOM for allowing you to test DOM things from a command line, not running in a browser. So it's simulating a DOM environment. And it can watch your source files and your test files, and if you change any of them, then it can just automatically run your test. So it's great when you've got a failing test, You just go work on it in any editor or IDE, and then off to the side, you see, oh, the test reran, they're still failing, you keep working until you get them fixed. There are a lot of alternative test frameworks in the JavaScript space, and I think there's not really anything wrong with these. I just like all the automation that is built into Jest. And so installing it is very easy. Running it, you just say Jest. It has really good support for mocking and spies. I won't spend a lot of time on this, but sometimes you have a function you're testing that calls something else. Maybe it's using the fetch API to call some REST service. You can mock it out and make it so that it always returns the same thing, so you can just test that function and not test the REST service. Then you could say, oh, I expect that my mock function was called, or even better, I expect that that mock function got called with certain arguments. So you can use it to test React components, but it's not specific to that. A really cool thing about Jest is that it supports these things called snapshots. Another thing that I'm going to fly by because it's specific to React, but the idea here is that you could say, I assert that this component renders the same thing it did last time. And that's all you say. So it's up to you to make sure that when you first run this test, it did the right thing now. And then in the future, if someone changes a div tag to a span, for example, the test is going to break because it didn't render the same thing it did last time. That's a really simple way to write tests for your components. The watch mode is a really important part of this. You just add -- watch to the Jest command, and then you can iteratively work on fixing your test. When you do it this way, you have all of these options to work with, and a really common one I use is P. So maybe I have a really large application with, say, 30 test files, and there's this one that's failing, and every time it reruns my test, I don't want to rerun all of them, and so I'll say P, and then I type in a regular expression that matches the test that I'm trying to focus on, and then it will only run that one. And it will tell me each time how many tests it skipped, so I'm not going to forget to test them again, but just temporarily I can focus on that. And when I'm done, I can type A to say run all of them again, Q to get out of this, and then W if I want to see all the options for the watch. Then in my test code, maybe I don't even want to run all the tests in this one file. I want to focus on one test function. And so I can go to that one function, and where it says it or test, those are synonyms. I could say test.only or test.skip. I don't want to run that one. Just so that I can focus on one thing that I'm trying to fix. Another thing I'll skip by pretty quick here is Enzyme, definitely specific to React. But the point here is that it makes it easy for you to find a thing in your DOM and then simulate an event on that. So I could find a button, I could simulate a click event on it, and then see what happens there. So some detail about Enzyme here that I'll skip over. So let's look at a demo of doing something with Jest. So right now, if I say npm t, test is one of those special npm scripts, so I don't have to say run, and I can abbreviate it to just t, and it's running all of my tests, and of course everything is passing now. But I want to go into my code and break something. So in my code, I have a place where I'm going to disable a button if I haven't entered anything yet. Let's see, is that true? Go back to my slide. Okay, so I have this function called handle name change. Yeah, right here. And I'm saying that the greet button is disabled if the length of the name is 0. Well, if I change the triple equal to a not equal equal, surely that's going to break something, and it did. Okay, I expected the value to be false, but I got true. And so right now, the tests are still running. And it's hard to see that far down on the screen, but if I type a W, it gives me all that help information, and if I just hit enter, it runs the test again. So if I come back over here and I fix my code, and save that change, that should trigger the test to run again. And they did, and now everything is passing again. So I spend a lot of time in this mode trying to get tests to work and having it automatically rerun, tell me if I've been successful. Okay, next thing I want to hit on is Istanbul. This is a tool for giving you a test coverage report. So it collects the information, it prints it out on the screen, it also writes it out to files, and then later you can pull that up. It gives you an HTML version of this report. I haven't found anything that is really comparable to this. It seems to me that everybody in JavaScript that cares about test coverage is using this tool. It turns out that this comes with Jest, and so if you've installed Jest, you don't have to install this, but if you were in some other framework, you could install it like that. And the way I like to set it up is that if I want test coverage numbers, I have this cover script, and it runs that, and it'll print out the results on the screen and save all the information in files, but it won't automatically pull up the report in my browser. So then I have a separate script, cover open, that's using that open command again, where if you're in Windows, you could use this opener thing, and I tell it to open the report. Now, I could try to combine these two things, but what I find is that if I have a problem with my test coverage, I'm going to leave that browser window open. And then when I think I've improved my test coverage, I'm going to run this again, and then I'll just go back to my browser and hit refresh, and I'll see the updated report. There are some cases where you might have some code that you think doesn't deserve to be counted in your test coverage. Like, this case should never really happen. It's in there just in case, but really this should never happen. And I don't want to be dinged on my code coverage because of that. And so I can put in a special comment in my code, Istanbul ignore, and tell it, ignore the next line, or ignore the next if branch, or the next else branch. And then it won't count against you. Maybe that's cheating. Maybe you should say, well, don't set your goal so high. It's not reasonable to try to hit 100% or even 90% coverage. And if you're not cheating and you can accept something reasonable, like maybe 80%, then you don't have to do that. So that's a debatable thing. To configure this, you go into your package.json and you add this Jest piece, and then you tell it where it's going to collect coverage from. So here I'm telling it every JavaScript file under the source directory, except this one kind of setup file isn't really doing a whole lot. I want to skip that one file. And then your coverage threshold. So I'm going for the gold here, trying to get 100% on every possible way of testing. And so if I don't hit those numbers, it's going to fail. So let's look at a demo of this. So quit out of my testing thing here, and then npm run cover. So a lot of green there. I've got 100% coverage. That's great. And so I'm going to run this again, cover-open, and it's going to open it up in my browser. Let's see which monitor this actually appears on. I have to take this out of full screen mode. Yeah, there it is. Okay, so here's my test coverage report. We'll blow that up just a bit. So I had just one file. It was testing demo.js. But the cool thing is that I can click on this, and it will show me detail about what wasn't covered. Now this isn't so interesting because everything's covered, but let's change that. So I'm going to go back into my editor, and I'm going to go over to my test this time, my demo test.js, and I have this one test here, handle name change. We're going to put a .skip on that test. And now, unless some other test case is covering what it was doing, I'm not going to get 100% coverage anymore. So I'll run npm run cover, and sure enough, I saw some red fly by there. I didn't have a failing test. It's just that I only have 83% test coverage now because of that. And so I'm going to go back to the browser, and I'm going to zoom in on this a bit and refresh it. And now it's showing me I've got 83% test coverage, and look down here. It's highlighting exactly what didn't get covered. So this is not my test. This is the code that it was testing, and I didn't have any calls to this function, and so it didn't execute these lines of code. It can even show you things like maybe it ran this function, but the function had a ternary in it, and you never exercised one branch of the ternary, and it'll highlight which one didn't get covered. Do that change, and then I should be back to my 100% test coverage now. Okay. Let's talk about Webpack. Webpack is notoriously known for being a tool that is difficult to configure. And I aim to show you that it doesn't have to be for simple use cases. So I'll show you one of those simple use cases. So the point here is that we want to take all our JavaScript files and bundle them into one file. And we might also want to take other kinds of files, like CSS files, and turn them into a JavaScript version of that and bundle it together too. It enables the use of ES6 import and export. That's what it uses to figure out what files are needed and then bundle them all up. There are alternatives, Rollup, Browserify, and kind of recently Parcel has been getting a lot of press. And maybe it's going to overtake Webpack. But for right now, it seems like Webpack is the most popular tool for doing this. It optionally can use these things called loaders, which is how you specify extra functionality that you want it to use. And that's where it gets complicated, is configuring these loaders. And so the most important ones, I think, are what I have up here. The Babel loader says, I want to run a transpiler on this code before it gets bundled because I'm maybe using some newer JavaScript features and they need to be transpiled. The CSS loader can check to see if any of your CSS files are using @import or this URL syntax to find other files relative to that one. Then the style loader is going to take the result of all your CSS and it's going to inject a style tag into your code where it needs to be so that it loads the CSS. And if you want to use a CSS preprocessor like Sass, the Sass loader will do that for you. So the point of these loaders, as explained in this box here, is to take things that aren't JavaScript and turn them into JavaScript or to do some extra processing in your JavaScript files. So here's how you install Webpack. If you need to use any loaders, you npm install -d all the loaders you want to use, and then in an npm script, you just tell it to run Webpack. We haven't looked at the configuration file yet. That's coming up on the next slide. But just like some of the other tools we've looked at, this has a watch mode, and so you can start it up and then go over to your editor and make whatever changes you want, and Webpack's going to see that you did that and produce a new bundle. And you can also, with a separate tool, set it up to refresh the browser and automate all of these things. One way to get that live reload is to use this Webpack dev server. So that's a really cool tool that combines the use of Webpack and live reloading. But I'll show you another way to get the live reload in just a bit. Here is a Webpack configuration file. So if you have relatively simple needs, like you just want to run Babel and you want to do this thing with your CSS, it doesn't have to be that complicated. The main things are that you have to tell it, where does your application begin? I begin with this index.js file. And the reason that's important is that it starts from there and it looks to see what does that file import. It looks at those, what do they import and what do they import? And that's how it figures out what to pull together into the bundle. And then the output, where should it put this bundle file it's going to produce? So this is the node.js way of saying, I want to put it in the current directory, but inside of that, I want to put it in the build directory and then create this bundle.js for me. Then I tell it about the loaders I want to use. So I want to use the Babel loader. I don't want to run Babel on things in the node modules directory. And I know to run this for any file that ends in .js. Run Babel on all my JavaScript files. And down here, for every CSS file I find, except ones in node modules, I want to do these two things. And this is where it gets a little bit odd. For some reason, these run in reverse order. So the first thing it does is the CSS loader, which looks for those imports and those URL functions in the CSS and resolves those. Then the style loader is going to inject a script tag for me in JavaScript form. And now all the CSS can get bundled together with the JavaScript. And then this watch true says, keep running, watching for changes to these files and produce a new bundle if any of them change. Okay, so let's look at a demo of running Webpack. And I actually already have it running up here in this top window. So I'm going to get rid of my build directory again. Message that flew by that said Webpack is watching the files. I do an ls and I have my build directory here. And let's see what is in that build directory. And interestingly now, the only file in my build directory is this bundle.js. Earlier when I ran Babel, I had a different version of all my JavaScript files. But now I just want to have the one bundle file. And then that's what's going to get loaded into the browser. And so if I pull up the browser window where I had this application running and refresh it, you should see what files did I actually need for that. And so here's my demo. And let me clear out my dev tools for the network demo. And then I'm going to greet myself here. Oh, gotta do refresh. Okay, and scrolling to the top here, I see that I have this local host thing that's loading my index.html, and then I have bundle.js, and there's a bunch of other stuff, but none of that is files from my application. Okay, and then the last thing I want to hit on is Browsersync. So again, if you're using something like Create React App or even Webpack Dev Server, you're getting live reload from those. But if you're not using those tools, this is another way to do it. And I think this is the simplest way to get it. What I'm after here is that I'm writing a web application. I have many files that are a part of this, HTML files, CSS files, JavaScript, and I want it to be that no matter what editor I'm working in, if I change a file, it will automatically reload the browser so I can see the impact of the change that I just made. And so I install it like this, and then I add this npm script to say run browser sync, and I want you to run a local server that is going to watch for changes, and then these are the files I care about. Because I'm using Webpack, I don't have to tell it to look at all of my files, because all of my CSS and all of my JavaScript is going to get put into this bundle file. So if that changes, I know I want to refresh the browser, or if I change the main index.html file. So, quick demo of that. I've got the application running right here. And so, if I go over to the editor and I make a change in my index.html and just change one of my labels, that should trigger it. Okay, so here's the name label. And it says name, I'm just going to add an R, so let's say namer. Okay, and then there it is. So I didn't have to refresh anything, it automatically did that for me. All right, so a wrap up of this. Yes, it takes a little bit of work to configure all of these tools, but you've got the slides. Each one in itself is pretty simple to set up, and I definitely think it is worth the time to go through that for all the automation it's going to provide you, all the errors it's going to check in your code that would have taken you much longer to find without these tools. So go give it a shot, try to set these things up on your project, and definitely shoot me an email if you get stuck on any of this. Any questions? Did I actually do that in an hour? No questions? All right, thanks for coming and drive safe.
Cool.